Hey mathematicians, today we are going to learn about scale drawings. So our learning target is, I can understand that scale drawings are figures that are identical in shape but not size, with side lengths in equivalent ratios. So we got some vocab we need to know. A scale is just the ratio of length in a scale model to the length of the real thing. So the scale model number always goes first, then the length of the real world item goes next. And then scale factor is the number used to multiply or resize a shape. So you've probably seen a scale if you've ever gone down the toy aisle and seen model cars. You might see 1 to 16 or 1 to 8 on the box. That means that 1 unit of the toy car is equal to 16 or 8 of the real car in real life. So let's look at number 1. We need to find the scale factor from figure A to figure B. So a couple of things that we need to note here is that we're looking for scale factor. That is, what number are we multiplying by to get from one to the other. And the next is that it says from figure A to figure B, so we are going from this one to this one. It does not matter which side we use as long as we use corresponding sides on each figure. Corresponding just means that those two sides are going to match up to each other. So I'm going to use the side length 6 here, and its corresponding side is 30. You can tell because if I look at this obtuse angle, it is the side that is on the right side of that obtuse angle. So I need to know what number is going to take me from 6 all the way to 30. Well, if we know our math facts, we already know what that is, but let's pretend we didn't. So 6 times something equals 30. Let's write an equation that shows that. 6 times something, we'll use x, you can use any variable you like, equals 30. Hey, that looks like a familiar setup of an equation. You solved these last year in 6th grade. We draw our line, we find our opposite operation. The opposite of multiplying by 6 is dividing by 6. Why does that work? Because 6 divided by 6 is 1. 1x is equal to 30 divided by 6 is 5. So our scale factor is 5. And if we wanted to double check that, we could see, is 9 times 5 equal to 45? Yes. Is 14 times 5 equal to 70? Yes. So we know we've got the right answer. Number 2, what is the scale factor from figure A to figure B? So let's make sure we're going from the correct figure to the correct figure. We're going from A to B. I like to draw the lines. We need to find corresponding sides. So I'm going to use this kind of top angle here, this acute angle. It looks like it's the smallest angle. This is the smallest angle. Make sure you're paying attention to like the size of the angle or the size of the side, because sometimes they'll rotate a shape. So I'm going to look at this small angle and I'm going to look at the largest side. So the one coming off of the right hand side, if you're looking down at the angle. So we've got a side length of 6 as figure A, so 6 times something, I'm going to use Z for funsies, is equal to 36. Again, this is one where we may know our math facts. We may know what to multiply 6 by to get to 36, but just in case we don't, when it gets tougher, we set up that equation so we know how to get there. We're going to draw a line through our equal sign and do the opposite of multiplying by 6. Divide by 6, divide by 6. 6 divided by 6 is 1. So 1z is equal to 36 divided by 6 is 6. We can double check it. Is 5 times 6 equal to 30? Yes. So we know that the scale factor is 6. Number 3 is a problem where you try it. You're going to find the scale factor from A to B. So you're going from this shape to this shape. Find your corresponding sides and then figure out what number you would multiply to get the figure A side to the figure B side. I'm going to have you press pause, try it, and press play when you're ready to check it. Please press pause now. Alright, so hopefully you solved that out and figured out that x was equal to, you could say 5/3 or 1 2/3 or 1.6 continuing. And it doesn't matter which side you use. You can see here I use the yellow shorter side, and here I use the green longer side. Either way, you get to the same numbers. We just have to simplify a little bit more when we use those longer sides. All right, number 4 is another you do problem. So you're going to want to pick whatever side you want, find its corresponding side, and then figure out what you multiply 1 by to get to the other. We're going from A to B. So please press pause now, come back when you're ready to check. Okay, you can see here that I chose to do the shorter side right here. So I said 3 times something gets me to 4. And then I set that up over here. You can see the answer is 4/3 or 1 1/3 or 1.3 continuing. Doesn't matter which one you go with. And then over here, I did, that longer blue side where I went from 12 to 16. So 12 times something gets us to 16. Still got us 4/3 or 1 1/3 or 1.3 continuing. You have to simplify a little bit, but we know that 16 over 12 simplifies to 4 over 3, so that ratio is the same no matter what. Okay, number 5 is an I do problem. They're asking, is figure B a scale copy of figure A? So if that is the case, then we can multiply all of the sides on figure A by the same number to get to their corresponding sides on figure B, or the ratio of all of those sides will be equal to each other. So I'm going to do figure A on top of my ratios and figure B on bottom. I'm going to find my corresponding sides, so 4 and 2, 4 over 2. Pretty easy to tell what that is. We simplify that, it becomes 2. Let's do this one next. We've got 10 and 5, so figure A was 10 over 5. Does that simplify to 2? Yes, it does. So next, let's do that bottom side, the longest side. We've got 10 and 6. And right away, alarm bells are going off because figure A still uses the number 10, but figure B is using a different number. You know, without having to do any math, that 10/5 is not equal to 10/6. So, is B a scale copy of figure A? No. The side lengths do not form equivalent ratios. Okay, let's go look at number 6. Number 6 is asking a similar question. Is figure B a scale copy of figure A? The figures are not drawn to scale. So first, we have to figure out how long those sides are. So figure A is 2 units tall. Figure B is 2, 4, 6 units tall. So we can set that ratio of 2 to 6. A to B is 2 to 6. Now we can look at that bottom measurement, the base. Figure A is still 2. Figure B, 2, 4, 6 is still 6. Is 2/6 equal to 2/6? Yes. Now, we don't have in 7th grade the skill set yet to measure that slanted edge, that longest edge. But the good news is when we're dealing with a triangle like this, if the 2 legs are if the 2 legs are forming equivalent ratios, then this longer edge has to form an equivalent ratio as well. So yes, we can say figure B is a scale copy of figure A. All right, I would like you to try number 7. See if you can figure that out. Press pause now, and when you're ready to come back and check your work, you can press play. Welcome back. You can see here I only looked at 2 of the sides. That's all I needed to figure out if this was a scale copy. The answer is no, because that short side on top of the trapezoid has a length of 2 in figure A and a length of 10 on figure B. That's 2/10. In the slanted side, you've got a length of 2 on figure A and 11 on figure B. We know that 2/11 is not equal to 2/10, so that cannot be equal, or rather a scale copy. Okay, let's go down to number 8. We've got a slightly different problem. A scale on a hiking map shows that 1.5 inches represents 4 miles. What number of actual miles are represented by 6 inches on the map? So we could solve this with equivalent fractions. We could say, let's say inches to miles. I like to set up, before I use any numbers, I like to write down the units. That way I know I'm putting the correct number on the correct side of my fraction. So 1.5 inches on top, 4 miles on bottom, because we put miles on bottom. They want to know what number of actual miles are represented by 6 inches on the map. So inches goes on top, next goes on bottom. And you know what? I'm struggling a little bit to solve this one, so let's try a new strategy. Let's make a table. I'm going to put inches here, miles here, and I know that it's 1.5 inch for every 4 miles. And I know I need to eventually get to 6 inches, but I'm not sure exactly how to get there the best way. So I do know that if I double 1.5, it gets me to 3. So let's double 4. So 1.5 over 4 would be the same as 3 over 8. Okay. Now to get from 3 to 6, I just double it, so I can double this again. And I would say that x has to be equal to 16. 16 miles. If I wanted to skip that middle step, could I do that? Yes. I could figure out what magic number will take me from 1.5 to 6 by doing 6 divided by 1.5, just like we did in our equations earlier, and find out y must be 4. So then I would do 4 times 4, and guess what that gets us? 16. All right, let's go down to y. Figure A is a scale image of figure B, so that's good, they tell us that. We have to find the value of x. So I'm going to go ahead and set up a table, and I'm going to compare A to B in my table. And let's start with this shorter side first. So figure A has a measurement of 4 units, figure B has a measurement of 3. And then on this longer side, figure A has a measurement of 7.2. Figure B, we don't know, it's x. So we need to figure out how to get from one number to the next. I'm going to see if I can figure out how to get from 4 to 3. So I know that 4 times something equals 3. We're going to solve that equation by dividing both sides by 4. 4 divided by 4 is 1. So y must be equal to 3/4. We don't need to actually do that division. We can just keep it as 3/4. That means if I take A and multiply by 3/4, I'll find B. 3 times 3/4 will get me to, or I'm sorry, 4 times 3/4 will get me to 3. So I can take 7.2 and multiply by 3/4 to figure out what x is. And that tells me x must be equal to 5.4, 5 and 4/10. Okay? Nope, went too far. Number 10, Alexander is drawing a map of the federal triangle in Washington, D.C. Okay, we've got a triangle, so immediately I'm just going to draw a triangle, so I have that on my paper. The actual federal triangle has a base of 3,000 feet, the base is down here, and a height of 1,200 feet. Okay? Alexander needs his drawing to fit on his paper, so he decides to make the base of the triangle 10 inches. We need to figure out the scale that Alexander is using. So remember, scale is the ratio of length in the scale model to the length of the real thing. So we're going to write a ratio, 2 numbers being compared, and we are given the base of the drawing and the base of the real thing, so let's use those 2 numbers. We do the model first, 10 over 3,000. Now, my fill in the blank here starts off with 1 inch. I have 10 inches here, so I got to figure out what would the equivalent be for 1 inch. Well, how do I get from 10 to 1? Divide by 10. To make this an equivalent fraction, I have to also divide by 10. That means that my scale must be 1 inch corresponds to 300 feet. So every 1 inch on his drawing really represents 300 feet in the real world. Now we can find the height of his triangle in inches. We know that 1 inch represents 300 feet. We know that in real life, the height of his triangle is 1,200 feet, or 1,200. Now I've got 2 ways that I can solve this. I can look at feet to inches, How would I go from 300 down to 1? I would divide by 300. That's one way. Or I could go from, how would I go from 1200 down to 300? I'm sorry, how would I go from 300 to 1200? I would multiply by 4. So I could multiply by 4. And you can see that one's a little bit easier to do with mental math, but either way, you're going to get the same answer, 4 inches. All right, we have problem number 11. Rena is building a 1 to 180 scale model of a real castle. That means 1 unit on the drawing or the model will equal 180 units in real life on her real castle. Her model has a rectangular base that is 3 feet wide and 4 feet long. We need to find the area of the base of the actual castle in square feet. So, looking at the model, it's 3 feet wide by 4 feet long. That's a rectangle. So the real castle will also be a rectangle. We need to find the area of that real castle. So I'm going to start by building out a table, and I'm going to do model to real deal. So the model has 1 unit to 180 units in the real deal. And let's start with that 3 feet wide. So that is the model. So that goes up here. And we're looking for the real deal. Well, I know to go from 1 to 180, I could multiply by 180. When I do that, I get 540. So that's the real footage of that wall in the castle. The other measurement of the castle is 4 feet. So I can do the same thing. I can do 4 times 180 and find that measurement and get 720. Well, that's all well and good, but they didn't ask me for the measurements of that rectangle. They asked me for the area. So to find the area, I would do 540 times 720, and we're going to get a crazy big number, 388,800 square feet. So now you've got the sum it up. I want you to write down what are the key takeaways from what we just covered, and then we will follow up with some practice problems in iReady.